What's the plan?
And we're trying to get everything consolidated and get a cohesive set of questions to ask you.
Roger, 15, we copy. That sounds real good. Appreciate it.
Anything else to report?
Well, we haven't talked about landing for several days.
Believe none of what you hear, question everything you see.
That's affirmative. That's affirmative.
Welcome to Richplanet TV. I'm Richard D. Hall. Now, over the years, Richplanet has delved into many different areas and focused on some areas more than others. One of the subjects which has been touched on is energy.
We live in this sort of sea of energy which we can't normally perceive.
If I get a piece of space above my desk, 1 foot by 1 foot by 1 foot, that space, okay, and I take out all of the air from it, so it's pure space. What he's saying is locked in there, just in space itself, is a sea of energy which is almost infinite.
There seem to be a number of methods where you can extract energy from this zero-point field.
Right.
It's a question of how easy it is to build it and how much energy you can get out to do anything that's useful. You know, you get various sort of claims that are made, some of which seem to be more reliable than others. But if you look at the work of Tesla and some of his experiments, and there's a chap called Paulsness, and he's reproduced some of Tesla's original experiments. But that description, and the fact that it was based on the homopolar generator, the moment you described that to me, because I wasn't actually aware that that's what the Trombley device was based on, the Faraday homopolar generator, that immediately reminded me of the N machine, which was developed by Bruce De Palma, who was he was also at MIT. And he developed this, as I said, N machine, which he also claimed could produce energy 5 times more than you put into it, and that was also based on a homopolar generator.
My opinion is you're never going to find out unless you build one.
Right.
We were saying before, is this linked into the Maxwell's equations and the missing part of Maxwell's equations?
Correct, that's right. And if you look at Maxwell's original equations, my understanding is that the original equations that Maxwell came up with had extra dimensional elements in them, outside the normal 3 dimensions, which he had realized were relevant to explain, the way that electromagnetic fields, went through a vacuum and this sort of thing. And it was apparently Gibbs and Heaviside, 2 mathematicians, who took Maxwell's original equations and said, oh yeah, we can understand what you're saying here, Maxwell, but actually for most of what we're doing in physics at the moment, we don't need all these extra dimensional terms. They're just introducing extra complexity which we don't actually need, because that's nothing to do with any observed phenomena that we normally observe. And so they threw all that away, and what went forward into the mainstream physics from that point was a reduced set of Maxwell's equations, which everyone obviously took to be the full set, and they weren't.
And Maxwell's equations describe electric fields and how that relates to charge. They also describe how the sum of a magnetic flux through a Gaussian surface is always 0. I know this might mean nothing to some viewers, but in Faraday's law, that a time-varying magnetic field induces an electric field. And there's also Ampere's circuit law. So they're basically the laws of electromagnetism and electricity.
Right.
That's what they describe.
Right. And my understanding is that Maxwell was able to calculate the speed of light from his own sets of equations, and that was later verified by experiment completely independently of what Maxwell had worked out theoretically. 1920s, 1930s, when they were starting to get big oil companies going and big energy companies, Tesla was doing it at that sort of time, and Maxwell's work was really a forerunner to that. So if we take the view that there are certain people who have more knowledge than we do, they could probably see the way things were going to go in science, and so you can imagine they would need to make sure that Maxwell's equations were watered down to slow down the pace of discovery that would maybe lead people to a source of free energy in these extra dimensions, for example. Essentially, they pass information to a third party, which then decides whether
there's anything to it.
Yeah, whether they buy the person out, or they wrap them up in legalese, or they offer them a business plan. In a restaurant. Yeah, or poison them in the restaurant, which we'll probably come on to,
right.
And so on.
It's a tangled web. If somebody does produce something which appears to solve the energy crisis, really, there's only one way to go, is to not patent it, is to not go for investment. Really, I would suggest that you put out all the information on the internet and try and spread it as much as you can before people would then say, well, you're not going to profit from the idea. But I would say that if you're going to change the entire human race and everything on this planet, then thinking about your own pocket is really a little bit short-sighted.
Absolutely, and there's a number of people that have done exactly that. I mean, John Hutchison doesn't patent anything, for example. And it appears also that we have this, and I don't know the full details, there is a village in Switzerland, I believe, where they say they have a free energy generator, sort of tucked away, and it's powering their village, and they keep this thing sort of well under wraps.
Oh, really?
Now, I set up a study group in 2015 to look into energy devices, but we only had 2 meetings, and I was soon diverted onto other investigations and left this subject sitting on the shelf for 10 years. Now, one device I looked into was the Stan Myers water fuel cell.
Now, the thing about the Myers fuel cell is that it was alleged that it broke the law of conservation of energy. So in other words, the amount of electrical energy to create the hydrogen and oxygen was less than the amount of energy when the hydrogen and oxygen is burnt off. Now, most scientists would immediately dismiss that such a device could work without even looking at it. Now, I don't belong to any company, I don't belong to any organisation, I don't work for the government, and what that means is that I can look at inventions such as the Stan Myers water fuel cell and investigate them without being ridiculed, without having any pressure or peer pressure for someone saying, oh, why are you looking at that? It's obviously a fake. I'm not arrogant enough to say, well, that can't possibly work because it breaks the law of conservation of energy. But at the same time, I'm not ignorant enough to say, oh, well, that must work because he was poisoned in a restaurant. Further investigation is required. I believe the only way you can find out if there's any truth about this device is to try and build one yourself, and that's what I've been trying to do. Essentially, Myers took his water fuel cell and he incorporated it into a motor vehicle, so he's driving around America in a car, a buggy, that's powered by water. A car powered by water. Imagine the ramifications to the planet if you can produce a car that you could just fill up at your local reservoir. Think about it, right? Now, and think about why Stan Myers may have been murdered. So we've got 2 stainless steel tubes, one inside the other. That then goes inside water. We then apply pulsed electricity across these 2 electrodes. I'll switch the pulses on and we should see the pulses on the oscilloscope. So key number 1 turns the pulse train on, and we can see here on the oscilloscope I've actually got six pulses running at 10 kilohertz, followed by a space of 500 microseconds. So this is known as a duty cycle, and this is what the Stan Myers equipment supposedly ran on. He would have 5 or 6 pulses, or maybe more, between maybe 4 and 12 pulses, on off, on off, on off, on off, followed by an off period, and then followed by the same set of pulses. And the overall time is known as the duty cycle. All right, but we can also modify the pulse width. Now, I've written this control screen here in order to modify all of the different aspects of the pulses. So, for example, I can actually add in another pulse in there. So I can change the number of pulses. So if I just hit Q, there we go. I've got an extra pulse in there, and then another one, and another one. Okay, so I'm adding pulses into that signal. I can reduce them, go down to 4, now down to 3. All right, so now I can also modify the speed of the pulses, or the frequency, by increasing the width. Now I do this by pressing P, and then you can see there, they're just getting slightly longer. So that's slightly higher than 10 kilohertz. Sorry, lower than 10 kilohertz there. All right. Now the other thing that I can do is I can modify what's called the Mach space ratio. So in other words, I can make the on time longer than the off time. And this, I think, is quite important for this device. I can also modify the duty cycle. So I can modify the time that the pulses are off for. We can do this by pressing the U and H key. So I've got pairs of keys on the keyboard. You can see there the gap between the 3 pulses is just coming down. There we go. Or we can increase that. So I've got ultimate control over these pulse trains, and we can go up to about 80 kilohertz. And then the hydrogen oxygen then bubbles off and then can be collected and used to power an engine or what have you. That's the principle of the Myers device. The circuit that I've built here is based on the Myers 8XA circuit. If you want to look up that on the internet. Your pulsed DC comes out of the voltage intensifier circuit. It goes through the coil, across the electrodes, and then it comes back and it goes through the coil again. So you've effectively got 2 coils either side of your capacitor or your water cell, because electrically this is effectively a capacitor. So you've got an inductor either side of it with pulsed DC voltage going onto it. And according to Myers, it's the fact that you've got these 2 inductors either side of the cell which is important. He talks about resonance. Now I'm dubious as to whether there's any resonance in this. I think it's more of what I would describe as a pumping circuit, because you're getting pulsed DC and each pulse raises the voltage each time, and then what happens at some point when the voltage gets to a particular level across the plates, the water cracks and creates hydrogen and oxygen. The voltage is 100 volts. We've got just under 2 amps, so we're just under 200 watts, and you can see there's quite a lot of gas coming off. Now it would be a question of collecting that gas and measuring the volume and ask, well, is it higher than the 200 watts? Skeptics would say that hydrogen and oxygen is just a result of bog standard electrolysis, but I wouldn't know until I've measured it. You see, that the current there, in my opinion, is too high. That needs to be limited in some way, but in a way that the gas still comes off.
Energy is fundamental to life, more fundamental than money, politics, or even matter. Energy is required for just about everything, even to create digital commodities such as Bitcoin. Energy flows through empty space, and it is the driving force behind all life. Empty space is more fundamental than the energy which flows through it, however, but perhaps we'll get into that more in later episodes. Energy is the driver of all forms of communication and plays a role in consciousness. What could be more worthwhile than exploring and understanding energy and how it manifests itself in our world, and investigating whether energy can be obtained in ways that are not widely known about? Over the last 4 months, I have been investigating devices which are alleged to produce energy in ways which could replace conventional energy generation technologies such as fossil fuels, nuclear power, solar energy, etc. This is a huge field of research, and a controversial one too. In order to stand any chance of success, it requires dedicated attention over a significant period of time. I am changing the focus of Richplanet and dedicating my efforts to this field, at least for the near to mid-term future. And the project will operate under the name Richplanet Power. Power being the rate of flow of energy. It also has other meanings. The project involves research, but more importantly, it will involve building experimental devices, machines, or experiments in order to attempt to prove or disprove certain claimed concepts about energy generation. I have spent some time in recent months designing, building, and testing an experimental device based on the homopolar generator, invented by Michael Faraday, which some researchers have claimed can generate more electrical power than the external power required to drive it. Thus, they claim, seeming to break the first law of thermodynamics, which is why we need to be skeptical about it, but realize that such claims can only be dismissed after a full investigation. Investigation and building of more experimental devices will follow in the coming months and years. The controversy over whether there is any truth to the many claims about energy generation, in my opinion, is caused because of a gulf which exists between the academic world of discovery and the independent world of discovery. And by that I mean non-establishment inventors and researchers. The two camps do not meet in the middle. Universities do not send researchers to look at independently developed devices, especially if claims are made which seem to break the laws of physics. Academia has a set of well-established laws of physics which can only be modified if a rigorous, repeatable demonstration is in the first place examined by academia and can then unequivocally show that something new has been discovered. This must then satisfy all the peers in the peer review process. If an independent researcher makes claims of something which might represent a new discovery in physics, it will, by definition, break or cause a change in the accepted laws of physics. As soon as academia realizes that a claim of this nature has been made, there is always reluctance by academia to even look at the claim. We know that cannot work, so if we look at it, we will look like fools, even when we prove that it doesn't work. To them, such claims are a poisoned chalice. So the door is often closed to researchers who operate outside of academia. Another possibility is that investigation may show that such a device does not break the laws of physics, but does do what the inventor claims, and there is an explanation which has been overlooked as to why both are true. There is also the aspect of funding. People who work in academia can only investigate something that has been approved and funding provided, the funding often being decided by non-scientists. And there is the hive mind mindset which operates within academia. For one scientist to go against the rest can be very detrimental to their career, so they normally follow the herd, even when the herd is wrong. The gulf between academia and non-academia exists in many other areas of research, not just energy. Now, it is a fact that every patent application is screened by intelligence agencies to determine whether that new invention should be suppressed on grounds of national security. There are very good reasons for this. If someone invented something that could be made with household items that could completely block out the sun from the whole planet, for example, you wouldn't want the whole population knowing how to make one. There'd be a good reason for suppressing such an invention. But that is an extreme example, and we do not know the full extent of devices that have been suppressed, because they're suppressed, some of which may be of benefit to humanity, such as new forms of energy generation. Some energy generation technologies have been suppressed, not by the patent process, but by academia. One example is cold fusion, or low energy nuclear reaction, the replication of which has been demonstrated independent of academia. Richplanet Power will be looking at existing claims that have either not been looked at by academia or unfairly debunked by academia, and trying to bridge the gulf, shine a light on the subject, and attempt to establish the truth about energy generation technologies. This is going to take time. It requires research, it requires time to design devices or experiments, and it takes time to build them, and of course, it will be limited by a tight budget. Therefore, my output of video reports will be far less frequent than in past years, but hopefully will be of interest to all when there is something to report. As I mentioned, the first device or claim I have looked into is the homopolar generator, which I will be reporting on in the next video. For those who don't know, I am qualified in this field with an honours degree in electrical and electronic engineering, and I worked as a professional engineer in this capacity for the best part of 20 years. So that's where my skills lie. Now, I am just as sceptical about claims of so-called free energy as anyone in academia is. But unlike them, I am prepared to investigate them. I don't necessarily expect to find any free energy device or any free energy or energy from the quantum vacuum. But unless you look properly with an open mind, you will not find it. And that means looking outside of academia as much as it does within. There are many devices to look at, and I do hope to get closer to the truth about some of them, whether they work or not. And if there is one that works, find it and prove it with a physical demonstration. That would be the ultimate goal. It may take years and to some seem impossible. It may never arise, but I think it's a worthwhile endeavour for the coming years. Bear in mind that if a particular concept is shown to have promise, it may require significant engineering and development to create something usable once a concept has been proven. And I hope to be joined by Andrew Johnson and possibly others along the way to discuss some of the many issues about the subject of energy. If anyone has any ideas, please email me at richard@richplanet.net. If anyone believes that there is a device or a concept that should be investigated, please get in touch, richard@richplanet.net. Now here's a short video showing the homopolar generator which I built, which I named the Mini N machine after Bruce De Palma's devices. Some of these devices are alleged to be tapping into a source of energy which is as yet not fully defined. Energy from what's known as the quantum vacuum. Energy from within the fabric of space itself, according to some, is able to be extracted. If you go online, you'll see many of these devices discussed with lots of interesting debates, and a lot of people who come from the mainstream science, standard physicists, will say, well, no, that's not possible. But one comment I would make is that the vast majority of people who you will see discussing these types of devices online, very few of them actually go and build one. You can present as many equations as you like and state as many laws as you like, but the proof of the pudding is in actually building and testing something. A lot of them, a very high percentage, involve magnetic fields or magnets or magnetic coils. So putting energy into a magnetic field and then taking energy back out of a magnetic field using a coil or a permanent magnet. And it is that exchange of energy, because when you put energy into a coil, for example, that energy is stored in space around the coil. And then when that magnetic field collapses and the energy comes out of the coil, it's being extracted from space. And the claim is that if under the right conditions, you can more energy can be extracted from that space, which is coming from the energy which is inherent within empty space. Like I say, I don't know that it's true, but I'm very interested to find out, and I have been for many, many years, because I did look at a lot of these machines many years ago, and the one that stood out for me, and always has, is the homopolar generator. So the first one is Bruce De Palma, who his machine was called the N machine, which was a homopolar generator, and I will explain the principle in a minute. And the other guy was a guy called Adam Trombley. And now I actually spoke to Adam Trombley, I would say it was around about 2010, maybe a year either side. I rang him up because I was fascinated by his devices, and I just wanted to speak to him. I didn't do an actual interview where I put it out on Rich Planet, and I remember him telling me that they came and confiscated equipment from his lab. They were both independently looking at homopolar machines, and they both said that these can produce more energy out than in, and that energy is coming from the quantum vacuum, or whatever you want to call it. In a normal electric generator, it follows Fleming's right-hand rule, where you have three vectors at 90 degrees to each other. And if you do this with your fingers, you point them all at 90 degrees to each other. The forefinger is the field, the magnetic field. The second finger is the electric current, and the thumb is the motion. So if you move something through a magnetic field which is running that way, you get electricity induced running that way. And this is how all electric generators work. Now, in a standard electric generator, generally the electric current will be running in parallel, because as you all know, in your washing machine or your lawnmower or whatever, you have something which is spinning round on an axis, right? And usually the electric current is running along that axis, back and forwards around it like that. So your second finger is the current, your thumb is the motion going around. So the field is at 90 degrees going through the axis that it's spinning on. With the homopolar generator, this is all shifted through 90 degrees, right? So your current, your second finger, your current, which normally runs along the axis of rotation, right, points outwards from the axis of rotation, right, which is in the form of a disc. So I've got two copper discs here, which are 5 millimeters thick, and they're 180 millimeters in diameter. Now this is what I'm using for my copper disc. So what I've called it is a mini end machine. It's a mini version of what Bruce De Palma built. The reason why I'm using two discs and not one is because 10 millimeter thick copper cost a fortune to buy, right? So I could only find 5 millimeter thick at a decent price, right? So these are going to be screwed together. So it's effectively a 10 millimeter thick solid copper disc, right? So that will be, the intention is to spin that as high as you possibly can. The faster the better. If we can get it up to 3,000 RPM, great. If we can get it to 6, great. If we can get it to higher, even better, because the voltage produced is proportional to the speed. All right. So you have a magnetic field which is going to go through the disc as it's spinning, and what results then is a voltage between the center of the disc and the rim of the disc. So the shaft that you put on the center, you have to have a brush system which will take the electric current from there, and you have another brush on the outside of the disc which takes it from there. And typically these sort of systems, you're lucky if you're going to get 1 volt between the center of the disc and the outer side of the disc. Well, what's the point of that, you might think? Well, 1 volt but at a very large current. And this is why these devices are not used, because you've only got one conductor the electricity is being induced in, which means normally you would have a coil, but due to the configuration, you can't make a coil in this configuration. So you're left with extremely small voltages, but a high current, which is useless. You can't use it. For example, let's just take your microwave oven, for example. It's 750 watts. So if you wanted to power your microwave oven off 1 volt, you would need 750 amps, which is, it would be a cable like that. So De Palma, he used, on his copper disc, he used permanent magnets on both sides. So you would have the north side on one side and south on the other. So you've got the magnetic field running all the way through the disc. Both of them used co-rotating magnets, and this is a very important element of this as to why I think it achieves over unity, if indeed it does. Normally, you would have something generating the magnetic field here, which is fixed, and the disc would rotate. So you'd have an air gap, a gap between the magnet, which is stationary, and the rotating disc. But both Tromley and De Palma, what they did was they fixed the magnets to the disc on both sides, and they spun them together, co-rotating at the same speed. Now, intuitively, you think that that wouldn't produce a voltage because there's no relative motion between the disc and the field, right? But apparently it does produce a voltage. And by fixing the magnets to the disc, what that does is it gets rid of the air gap. And the air gap itself is what reduces the size of the magnetic field because it's a higher reluctance path. So by attaching the magnets, whether they be electromagnet or permanent magnet, to the disc, and rotating the whole thing it improves the efficiency of the machine, because your magnet is right up against the conductor. Now Trombley went a step further, because if you've got a magnetic field going through this copper disc, we all know the shape of a magnetic field. If you get a bar magnet, it goes up, comes out of the magnet, it goes back round, and then it goes back in like that. So it's circulating in 3 dimensions all the way around. It's doing this, right? Now when the magnetic field is going through the air, the size of that field is reduced, because air has a very low magnetic permeability, right? If you encase that field in a highly magnetically permeable material, it reinforces that field, and it makes the field stronger. So what Trombley did with his device, so he had several electromagnets on each side of his copper disc, and then he encased the whole thing in a magnetically permeable material, so that the field generated by the electromagnets was then captured inside the ferrite, highly permeable magnetic material, and then fed back round. So you've got if you imagine a field going round, all the way around, and it's outside the disc and then inside the disc, but when it comes outside the disc, it's been given a much less reluctance path, right? So that increases the strength of the field within the disc. Now, when I spoke to Trombley, he told me that one of his devices cost him over $100,000 to build, and you can understand why, the complexity of that, because the electromagnets are spinning round, so you've got to have a brushing system to get the electricity onto the thing. You've got to have brushes for the shaft, you've got to have a brushing system for the disc, and then you've got to build all of this ferrite material around it, and then you've got it all spinning at as high speed as you can. And I think his machine was something like this sort of size, size of this table maybe, and I think it had a cast iron sort of bed, some sort of machine bed. So yeah, that cost quite a lot. And De Palma's device some of his devices were quite big as well, this sort of size. There's one video where the actual magnets and the rotor are being lifted onto the bearings by a small crane. I would try and keep it simple. So I would use permanent magnets and not electromagnets, because then you haven't got to use brushes to power the magnets. And also build it slightly smaller. Now obviously if you build it slightly smaller, the voltage that you get isn't going to be as high. But the development in magnets over the last sort of 10 years, there's been quite an improvement in the performance of magnets, and you can now get neodymium magnets, which are much stronger magnets than you used to be able to get, right? So I'm having 2 magnets specially manufactured in China, and they are N56, which is the latest, highest strength magnetic material. So I'll be working with a material that Bruce De Palma didn't have access to, and the voltage output is directly proportional to that magnetic field strength. So if my magnets are twice as strong as De Palma's, it means that the voltage output will be twice as much. So what I wanted was a neodymium magnet, the size of that disc, but thicker, about 20 mil thick, with holes in it. And yeah, they gave me some quotes. So what I did was, there's a company in China, and I just submitted an email to this Chinese company that make magnets, and they came straight back with a price, which seemed okay. So I've sent them the drawings, and there's a month lead time on that. So I'm waiting for the magnets to come. And when they arrive, I've got to be very careful with them, because these are the strongest magnets in the world, and they're going to be like that. So it's going to be fun trying to assemble it with such strong magnets. They're going to want to stick to everything. Yeah. So that bit will be fun when I unwrap these. I mean, I would imagine they're going to have to send them separately, and also like in a big package. Otherwise, it goes through the post. Things are going to be sticking to them. So I'm just going to go through some of the parts that I've been working on, because I want to show them now, because I don't want to just produce the finished thing and say hey, this is what I built, because no one will believe that I've built it. Control panel. These pieces will go on the side. This is the new mounting block. The nylon rod, so they will open up like that. This is a 0 to 5 volts voltmeter. Whoops. So it's set the set point there. So now that this thing's got a brain, there's all sorts of possibilities going forward. I'm quite excited today because the magnets have arrived. Whoa! So there's one magnet there, the other magnet's on the other side. So they're pulling together obviously, but the bottom magnet is pulling towards a metal plate, which is obviously at the bottom of the box. So that's it there. So there's as I say, wow. So that's sticking on the bottom there. There's another one. God. Right. There we go. So see, it's hard to lift out because there's obviously more metal underneath there that it's sticking to. If I God almighty. You see it's pulling this whole box. Right, I've just had the press fit done. So the copper disc now is attached to the rotor. This magnet now at the moment is being pulled to that bearing because it's made of steel, but I can pull that off. So that's how it's going to be. And obviously the next stage is to get the other magnet and put that on top. And then once the top magnet is on, it's then a case of fitting this bearing. If physicists and engineers were honest, nobody really understands electrical induction. So we have Faraday's law who discovered this, which basically describes that if you move a conductor in a magnetic field, a voltage will be generated. So the rate of change of magnetic flux multiplied by n, which is the number of conductors, equals the voltage that you will get in this. Now with a homopolar device like this, we only have one conductor. So we've got a magnet here which is putting a magnetic field through this disc. If I was to leave the magnet still and spin the disc, we get a voltage produced between the center of the disc and the rim of the disc. Okay, that's induction, right? Incredibly, if I was to keep the conductor still and spin the magnet, you don't get any voltage produced in the disc. If you spin the two of them together at the same time, you do get a voltage induced in the disc. And this is suggesting that what's happening here is this magnet is changing the actual space within which this conductor is sitting. So the magnet is causing the space to be modified in some way, probably twisted in some sort of vortex, some sort of change in topology of the actual space itself. So when the conductor runs through that modified space, the voltage is then induced. It's highly curious that if you keep the conductor still and rotate the magnet, you don't get any voltage induced. Now, the thing with this configuration is that when you spin the magnetic field stays exactly the same because it's actually magnetized. So in other words, you've got north here, you've got south here. Alright, so when you spin it, you've still got north here and you've got south here. So there's no change in the magnetic field. The magnetic field is exactly the same when the magnet is spinning. Alright, it's the fact that you are rotating the disc through that magnetic field that produces the induction. Alright, now in a standard electric generator, what's happening is that magnetic field is changing all the time. So your conductor is experiencing, so let's just take one tiny piece of the wire inside your electric generator, one infinitely small particle. What's happening with that particle is it's getting north and it's getting south, and it's getting north and south. So the direction of the field is changing, usually 50 times a second in a standard electric generator. So the conductor in a standard electric generator is constantly seeing a fluctuating magnetic field. It's going that way, then it's slowing down, then it's coming that way, then it's slowing down and going that way. So the field itself is constantly changing in a standard generator at 50 cycles a second. So it's oscillating like a sine wave. This generator, completely different. What's happening with this generator is the magnetic field is completely fixed and the conductor is moving. This produces DC, direct current, because the magnetic field is fixed and the conductor is moving at a fixed speed and the electric current comes out. So it's constant. It doesn't change. It's not oscillating like in every other standard electric generator. This is different. There's no AC here. It's just DC. Now think about that. In a standard electric generator, you've got the field is oscillating and then the current is oscillating as well. So there's an exchange of energy within space like this, like a sine wave, up and down, up and down, up and down, backwards and forwards. So the energy is in an oscillation like this. It's changing. But with this generator, that's not happening. You've just got one flow, one direction all the time. So the magnetic field is the same all the time and the DC current is all the time. So this is the I mean, if you look at Faraday's law, it's actually incorrect because it doesn't work. It says that the change in magnetic field relative to time equals the voltage. Well, there is no change in magnetic field relative to time in this device. So is that the reason why energy can be extracted from the vacuum? Because it's only going ever in one direction. It doesn't oscillate. But hopefully we're going to find out. Now, this magnet, which is a N56 neodymium magnet, one of the strongest magnets in the world that you can get, if we compare that to Adam Trombley's device, because he used electromagnets. In Trombley's device, he used coils, which he supplied with 150 watts, and that produced 15,000 Gauss magnetic field strength. So this magnet is probably in excess of 15,000 Gauss, and this will definitely be a lot stronger than the magnets that Bruce De Palma was using, or at least the permanent magnets that De Palma was using. Now, I will be reporting fully on this in the next video. I don't know exactly when that will be. I will post a newsletter out when it is ready. So if you want email notification of when it is ready, please sign up to the richplanet.net newsletter, which can be done from the subscribe to updates link on the website. Remember, believe none of what you hear and question everything you see. I'm Richard D. Hall. Good night. I'm just having to tidy up at the minute because, as you can imagine, the house has become like a workshop and there's just bits everywhere, tools lying around everywhere. I just thought I'd point out this spanner set. I bought that when I was 17 years old, so this is 40 years old. Every spanner is still in there. I tell you what, I've had some use out of that. So if you're a young person and wondering whether you should invest in a tool or whatever, do it, because you'll use it for your whole life.